differentiate this function. So what you try to do is that now take the 2 out, that becomes a 2 d by dx of tan inverse x, which is 2 differentiating tan inverse x d by dx of tan inverse x is equal to 1 upon 1 plus x square. So 2 upon 1 plus x square. This is the end result of your problem. Dear children, if you had directly differentiated this using composite function differentiation, perhaps you would have taken more time to clear this problem as compared to the time that I have taken. Perhaps I have taken about 1.5 minutes to 2 minutes, where if you have directly gone for the differentiation, perhaps you could have taken more than 5 minutes as well. Well, I shall be taking one more problem for you to make understand. Find dy by dx if y is equal to sine inverse 1 minus x square upon 1 plus x square. Dear students, in fact, sine inverse 1 minus x square upon 1 plus x square, we do not have any formula equivalent in the simplest form for this. So what we have to do, we have to apply now multiple formulas. You look at the beauty of this problem is, we know that sine inverse theta plus cos inverse theta is equal to pi by 2. It means sine inverse 1 minus x square upon 1 plus x square plus cos inverse 1 minus x square upon 1 plus x square shall be equal to pi by 2. Since the function given is this, leaving this one center remaining there, then you get sine inverse 1 minus x square upon 1 plus x square is equal to pi by 2 minus cos inverse 1 minus x square upon 1 plus x square. Interestingly, this problem was the previous problem which has got the substitution as 2 tan inverse x. It means you can replace this by this equivalent structure. Look at, now it is going to be y is equal to pi by 2 minus 2 tan inverse x. It means if I want to find out dy by dx, instead of directly differentiating this function, I would rather prefer differentiating this because this is much easier than this. So I will find out dy by dx, that is d by dx of pi by 2 minus 2 tan inverse x. This is differentiating pi by 2 is 0 minus 2 into differentiating tan inverse x is 1 upon x square, 1 plus x square, that is resulting is minus 2 1 upon x square. Imagine the time that I have spent on this. It is much easier. So dear children, as and when you intend to differentiate any inverse trigonometric function, what you need to do is that always try to simplify that with the appropriate formulas. The way I have worked out, in the same way you try to work out the formulas equivalent to them and then substitute, go for easy simplification and then finally differentiation, which would reduce your much effort needed. Okay? Well, dear children, we are now focusing on topic 4, differentiation of exponential function and logarithmic function. Before we plunge on to the problem solving of differentiation of exponential function and logarithmic function, I shall now be giving you brief basics of how to differentiate the exponential function. Differentiation of e power x, the exponential function, is e power x. Please remember, differentiation of a power x is a power x into log a to the base e. So this is the differentiation of another exponential function a power x. Differentiation of log x to the base e, sometimes if we do not say, you have to assume that it is a logarithmic, natural logarithmic function whose value will be 1 upon x. Please remember, it is a positive x, always positive x. It is true for only x greater than 0. Now, dear children, I will tell you what is exponential function. A brief account I will give you. This function was invented by Jacob Bernoulli and Johann Bernoulli. These two are the brothers who invented exponential function, which is initially written as limit n tends to infinity 1 plus 1 upon n to the power of n as e. The same thing later was changed by Johann Bernoulli as limit n tends to infinity 1 plus x upon n to the power of n is equal to e power x. So, this particular problem, the exponential function, has a deeper relation with the limits concept as well. Please try to understand, this is also written as an exponential infinite series, that is sigma n is equal to 0 to infinity x to the power of n by n factorial as well, which is you can write as x by 1 factorial plus x square by 2 factorial and x cube by 3 factorial and so on so forth. In a similar fashion, we have logarithmic function, the series also, but as far as our present topic is concerned, it is quite irrelevant as far as to know that. Therefore, we will be moving further into the direction. Now, the exponential series definitions I have given you. Whatever we are now going to do is absolutely based on these functions differentiations that I have given you. To take one problem, say find dy by dx if y is equal to e power x upon sin x. It is a very simple problem having exponential function and trigonometric function. It is in the form of u by v. U by v, differentiation of u by v rule is equal to v u dash minus u v dash upon v square. So, using this rule I will be applying here, dy by dx is equal to the v square, that is sin square x, v u dash, that is v is sin x, differentiating e power x minus e power x differentiating sin x. Resulting is e power x sin x minus e power x cos x upon sin square x, that is e power x common factor sin x minus cos x upon sin square x. This is what your dy by dx. This is one problem. You can take one more problem to note to understand this further. Here find dy by dx, find dy by dx if y is equal to log cos e power x. Interestingly, this is a function which is having three functions. You remember, I hope you remember, I have taught you already G circle, F circle, H. You go back to my first class. When you intend to differentiate a composite function of three functions involvement, you start with log, g, then f, and then h. Similarly, here I would be doing, that is dy by dx is equal to d by dx of log cos e power x. That is, first differentiation will take place for log. What is the differentiation of log x? That is 1 by x. Whatever is connected into log will be coming into the denominator, that is cos e power x. Then later the issue is that since it is not x as it was in the formula, it is going to get differentiated again cos e power x. Again, when you take this differentiation, what happens? 1 by cos e power x will remain as it is. Here it is going to first differentiate cos. What is differentiation of cos x? Cos x differentiation is minus sin x. Here cos has got e power x but not x. So therefore, first you differentiate it and write it as sin e power x into, again differentiating the one which is not the x, that is e power x. So what happens here? This is again 1 upon cos e power x sin minus sin e power x into differentiating e power x is e power x. It is like tan e power x into e power x, sin theta by cos theta. Therefore, dy by dx is equal to minus tan e power x into e power x is your answer. Well, dear children, the topic number 5 is logarithmic differentiation. Now here I want to tell you one thing. I have written two words, why and how. Let us first understand why. Why logarithmic differentiation? It is a very interesting question, you must know, and because this is a topic which is going to fetch you 4 marks definitely in the examination. Here logarithmic differentiation is mainly used for the purpose of when the function that is to be differentiated has another function in its exponent. See, here I have already taken sin the x. Instead of x, say for example, I take cos x. Why? Because the function is on the top. It is even if you say, sir, can we apply x to the power of n rule as n into x to the power of n minus 1? This rule is not applicable, mainly for the reason the power of the function is not a number. So, since it is not a number, it is imperative, it is mandatory, it is compulsory for us to bring this function down. This can be done only by logarithmic function. So, how to go about this? Just watch carefully. So, for example, if I say find dy by dx if y is equal to this. Now, interestingly, how am I going to proceed in this problem for solution? Look here. Take the function sin x upon sin x to the power of cos x. Now, taking logarithms on both sides. So, now taking logarithm, you get log y is equal to log sin x to the power cos x. Now, what happens in this case? Log of sin x to the power of cos x is going to facilitate a formula which we have already learned. Log m to the power of n is equal to n log m. Using this formula, this rule rather, I am going to bring the cos x into this format. That is log y is equal to cos x into, it is in the place of n rather, log sin x. Now, the function which we are not able to evaluate, differentiate, now has been made to form which is possible to differentiate. So, now I will take differentiating both sides with respect to x. What happens now? D by dx of log y is equal to d by dx of cos x into log sin x. Resulting differentiation of log y is 1 by y, dy by dx is equal to, it is a product rule. Product rule is d by dx of uv is equal to uv dash plus vu dash. That means cos x differentiating log sin x plus log sin x into d by dx of cos x. That is cos x differentiating log sin x is like a function of function. First log is differentiated, you get 1 by sin x. Again differentiating of cos x, sin x is cos x. So, you get it is cos x by sin x plus log sin x into differentiating cos x is minus sin x. So, simplify it, 1 by y dy by dx is equal to cos x cot x, that is cot x into cos x minus log sin x into sin x. So, this is why you bring that side, it becomes dy by dx is equal to y into cot x into cos x minus log sin x into sin x. That is y is again replaced by its earlier function, that is sin x to the power of cos x into cot x cos x minus log sin x into sin x. This is the result of the problem which you are supposed to be doing for the dy by dx here. Dear children, you must have realized here one important fact. What is that fact? Here when you observe this function, logarithmic differentiation is it has a main role to bring this function which is there as a power, the index of this function, base function to the down. Unless you bring this top function to the down, you will never be able to differentiate. So, please remember, logarithmic differentiation has a very prominent role in completing this kind of, the differentiation of this kind of functions which have got exponential functions here. There is sin x to the power of some other function here. Had it been a number, perhaps I would not have bothered even to go for logarithm, I would have completed it. Since it is not a number, I am supposed to take it down, then only I can complete the differentiation. Please remember, this is a vital area which you have to focus a lot. Dear children, I will be taking the last and final problem on the logarithmic differentiation, but the problem which I chose is a very, very important problem. This kind of replications are many to come in your CBSE examination. You need a sufficient practice. Now let us start with this. This problem, it is x to the power of sin x plus sin x to the power of cos x. Now the thing is that here you have got these two functions separately. This function I have already taught. Had it been alone, perhaps I would have followed directly logarithm. But in this case, there is a plus and coming together. So in this case, I will not be able to directly solve this problem. What am I supposed to do? Look at, first I will take dy by dx. It is, say for example, it is p function and it is q function. I will write it is d by dx of p plus q. Interestingly, I will write them as d by dx p plus d by dx q, because we know already summation of two functions will always be taken individually. So now what I am going to do, this is my first part, part 1 I will be completing, this is part 2. This differentiation I have already completed, so I will be focusing on this. So what I am going to do, first of all, dp by dx I will be finding. Now how to find out dp by dx? Take the function p, x to the power of sin x. Separately I have taken, because I have already assumed it as a p. So I have taken p. Take logarithm on both sides. Log p is equal to log x to the power of sin x. Then resulting what it is, I told you already, log m to the power of n is equal to n log m. Using this rule, here it becomes sin x into log x. So log p is equal to this function. Now I will differentiate, that means d by dx of log p is equal to d by dx of sin x into log x. So differentiating log p is 1 by p, differentiating p is dp by dx. So interestingly, you got the one which you require, is equal to here uv rule, that is u differentiating log x is going to be log x